area volume problems. Woo!
Yay! So the problems that we're going to use today, we'll use f of x is equal to 1/4 x squared plus 2, and g of x is equal to the square root of x plus 4, which are graphed there and there.
To find the point of intersection between the two lines right here, you set the equations equal to each other, find the value for x, and then plug that value of x into either of the equations to find the y value.
A way to estimate the area underneath a curve for a certain area is to use a Riemann sum. That takes a bunch of small rectangles with a length equal to d of x and a height of equal to f of x to approximate the area. This technique is how they came up with the way you can calculate it for real. Right.
In order to solve number 1, which says find the area under f of x from 0 to 4, you take the integral from the parameters you're given of the equation that you're given in the question, and
to solve problem number 2, which is finding the area between the two curves, f of x and g of x from 0 to 4, we take the integral from 0 to 4 of g of x minus f of x. You take the one on top and subtract the one on bottom, and that equals 8.
in order to solve number 3, which is find the volume of the solid created by rotating the area under f of x from 0 to 4 about the x-axis, which is this area right here over this axis. You take pi times the integral of this function squared times dx, which ended up being 157.449.
We solved this using a process known as disk method, where basically all the rectangles from that we used in the other thing become disks after being rotated all the way around, and it's just an infinite number of little disks. And since the equation to find the area of a circle is pi times the radius squared, this is pi times the radius squared. Now, problem 4 has us find the volume of a solid created by rotating the area between f of x and g of x around the x-axis from 0 to 4. This is done by taking pi times the integral from 0 to 4 of g of x, the top function, minus f of x, the bottom function, squared, dx. And this equals 21.8385.
To find the answer to this problem, use the method called washer method, which is basically taking the disk method of g of x, but subtracting the disk method of f of x, because you're only looking for this area right here, flipping over the x-axis.
In number 5, we are going to calculate the volume of the solid formed by y equals x squared minus 1 and y equals 3 when rotated around the horizontal line x equals negative 2. To find the volume of the solid, we have to take the area of a given disk times dy and integrate it over the given interval, which is y equals 3 and negative 1. The reason we are doing everything with respect to y is because we are rotating around a vertical line. So when we solve y equals x squared minus 1 for x, we get x equals the square root of y plus 1. To find the radius, we take the square root of y plus 1 and subtract negative 2, which gives us the square root of y plus 1 plus 2. And then we integrate, and our answer is 136 pi over 3.